Fundamentals of digital image. Visual perception. In presenting the output of an imaging system to a human observer, it is essential to consider how a viewer transforms it to information. Visual perception is important to image fidelity, which aids in field of image processing algorithm and image systems. Visual image data itself represents spatial frequencies of an object. The perceived information may be represented by attributes such as color, brightness, etc. Structure of the human eye. 3 membranes enclose the eye. These are the cornea, sclera and choroid, retina. At its anterior extreme, the choroid is divided into the ciliary body and the iris. The latter contracts or expands to control the amount of light that enters the eye. Elements of visual perception. When the eye is properly focused, light from an object outside the eye is imaged on the retina. 2 kinds of light receptors distribute on the retina, cones and rods. Cones are primarily located in the central portion of the retina, called the fovea, and are sensitive to color. They function best in relatively bright light, so cone vision is called bright light vision. Rods are distributed over the retinal surface. Rods serve to give a general overall picture of the field of view. They are not involved in color vision and are sensitive to low levels of illumination. Rod vision is called dim light vision. Around the region of the emergence of the optic nerve, there are no receptors, and this results in a so-called blind spot. Humans usually have 3 kinds of cones with different photopsins, which have different spectral response curves, resulting in trichromatic vision. Interestingly, some people have 4 or more types of cones, giving them tetrachromatic vision. 3 types of color-sensitive cones are there in the retina of the human eye, corresponding roughly to red, green, and blue sensitive detectors. Wavelength responsiveness of rods compared to that of 3 types of cones. The dashed gray curve is for rods. Image formation in the eye. Muscles within the eye can be used to change the shape of the lens, allowing us to focus on objects that are near or far away. An image is focused onto the retina, causing rods and cones to become excited, which ultimately send signals to the brain. Perceived brightness is not a simple function of intensity. Visual system tends to undershoot or overshoot around the boundary of regions of different intensities called as Mach bands. A region's perceived brightness does not only depend simply on its intensity, but on its surrounding regions. Such a phenomenon is called simultaneous contrast. Optical illusions. Our visual systems play lots of interesting tricks on us. It is still not fully understood yet. Light and the electromagnetic spectrum. Light is just a particular part of the electromagnetic spectrum that can be sensed by the human eye. The electromagnetic spectrum is split up according to the wavelengths of different forms of energy. Wavelength lambda equals c by f. Photon energy E equals hc by lambda, so E equals hf, where c is the speed of light and h the Planck's constant. The colors that we perceive are determined by the nature of the light reflected from an object. In addition to frequency, 3 basic quantities are used to describe the quality of a chromatic light source. Monochromatic light, light that is void of color. Chromatic light, light that spans the electromagnetic energy spectrum from 0.43 to 0.79 micrometers. Radiance, the total amount of energy that flows from the light source, measured in watts. Luminance gives a measure of the amount of energy an observer perceives, measured in lumens. Brightness, it is a subjective descriptor of light perception that is practically impossible to measure. Fundamental steps in digital processing. Please view the diagram. Image acquisition. Image acquisition is very simple. Images are already in digital form. It involves pre-processing, which is called scaling. Image enhancement. Image enhancement technique is used to improve quality of an image. It is familiarly used in digital image processing. It is a very simple technique. Subjective area of image processing. Image restoration. It is used to improve appearance of an image. This is the objective area of image processing. This is based on mathematical or probabilistic model of image degradation. Color image processing. Extracting features of interest in an image. This is an area that has been gaining in importance because of significantly increased use of digital image over Internet. Compression. Compression is used to reduce storage required to save an image, bandwidth required to transmit it. Morphological processing. It deals with tools for extracting the imaging components that are used in representation and description of shape. Segmentation. Segmentation is defined as partition of images into its constituent parts or objectives. This is a difficult task in image processing. It gives accurate results. This represents a successful solution for imaging problems. An erratic segmentation algorithm almost always guarantees eventual failure. The more accurate the segmentation, the more likelihood of success. Representation and description. Representation. Representation, which follows the segmentation stage, is usually raw pixel data constituting either boundary or region. Boundary representation. This is appropriate when focus is on external characteristics such as corners and inflections. Region representation. This is appropriate when focus is on internal characteristics such as textures and skeletal shape. Representation is transforming of raw data into forms suitable for subsequent computer processing. Description. It is defined as specialized for describing data so that features are highlighted. It is used to extract features of attributes that result in some quantitative information. It is also called as feature collection. It is a process that aligns a label to an object based on its descriptors. Components of image processing system. Please view the diagram. Image sensor. With reference to sensing, two elements are required to acquire digital images. These are sensor, digitizer. Sensor, a sensor that is sensitive to energy radiated by the object. Digitizer is a device for converting output of physical sensing device to digital forms. Specialized image processing hardware. It has a digitizer and hardware which perform primitive operations such as arithmetic logic unit. ALU performs arithmetic and logical operations for entire images. ALU is used for reduction of noise in images. This hardware is also called as front-end subsystem. Computer. It can range from PC to supercomputer, used to achieve a required level of performance. Software. It has specialized modules to perform specific tasks. Mass storage. Storage capability is important in digital imaging processing. It consists of three types of storages. These are short-term storage, online storage, archival storage. Short-term storage is used during processing. Online storage is used for relatively fast recall, and archival storage is characterized by infrequent access. Image display. It displays images. Hard copy devices used for recording images includes laser printers, film cameras, heat-sensitive devices, inkjet units, digital units such as optical and CD-ROM discs.